Today is the second day we are working on solving equations with the variable on each side. Our first equation, the directions it asks us to solve, and it says 5x plus 5 is equal to 3 times the quantity of 5x minus 4 minus 10x. So I'm going to draw my wall. And again, I have parentheses, so I need to clean that up. So I have 5x plus 5 on the left-hand side. On the right-hand side, my order of operations again tells me I need to get rid of my grouping symbols, which is my parentheses. So 3 times 5x gives me 15x. 3 times negative 4 gives me negative 12 minus 10x. My left-hand side is good. I just have a variable and a constant. My right-hand side, I'm going to combine my variables. So I have 15x minus 10x gives me 5x minus 12. Now I'm going to bring my variable to one side. So I have negative 5x either side, and I have 5 is equal to negative 12. Now we know this is not true, right? That means not true. That symbol with an equal sign with a line means not true. So 5 does not equal negative 12. So this is a special type of equation, and what that means is there is no solution, because that's not a true statement. It means no matter what number I put in for the variable x, I'm not going to get a true statement. So my final answer in that case is that there is no solution. Now if I go back a couple steps to where it says 5x plus 5 is equal to 5x minus 12, that's an indication that something's not right, because I know in the end, looking at that statement, when I subtract the 5x either side, I am going to get something that says 5 is equal to negative 12, which I know is not true. In the end, that's no solution. But this step right here does give you, it's like a little red flag telling you that something's not right about this equation. In my next equation, I have 3 times the quantity of 2b minus 1 minus 7 is equal to 6b minus 10. So again, I'm going to get rid of my parentheses by distributing. So I get 6b minus 3 minus 7 is equal to 6b minus 10. On my left-hand side, I combine my terms. I have 6b minus 10 is equal to 6b minus 10. Now we're going to go back to that step in a little bit. This, if you notice, it's the same thing on either side. So what I'm going to do is I'm going to keep solving. I'm going to bring my 6b to the other side. So that will zero out. So I have negative 10 is equal to negative 10. Now that is a true statement. So what that means is all real numbers will work. All real numbers is the solution, because it doesn't matter what value I stick in for b, I'm going to get a true statement on either side. We also call this an identity, which means the same thing. It doesn't matter which value I put in for b, I'm going to get a true statement. And again, if I go back to this statement right here, that's an indication it's the same on either side. My next problem says find the value of x so that the figures have the same area. Now this is a little bit more involved than the problems we've been doing so far in this lesson. So let's think about the formula for area. Area is equal to length times width. So I do have some missing values there. I have x on either diagram, so I know the area is going to be length times width. So on my red diagram, that's going to make it 10 times x, which is 10x. On my blue diagram, I know I'm going to have 6 because that's my width. And my length I'm going to actually add these together, right? If that x were a 2, I would say that side was 3 plus 2. So I'm going to do the same thing with my variable. So it's going to give me 3 plus x. If I keep going to solve it, I have 10x is equal, now I'm going to distribute 18 plus 6x. Bring my variables to one side, and I have 4x is equal to 18. Divide both sides by 4. Now I'm going to get a decimal here, and that's okay. It's going to be 4.5 centimeters, because again my units are centimeters. Now I can try, I would love to be able to verify that that's true. So if I kind of plug in 4.5 back in my diagram, and in my red diagram, if I have 10 times 4.5, that's going to give me 45. And I'm wondering if that equals what I have on my blue diagram, my rectangle there. So that gives me 6 times, and then 3 plus 4.5 gives me 7.5. That also equals 45. So I have 45 is equal to 45. So I know that 4.5 centimeters is the correct value for x. My last problem for today is similar to the last one. It says find the value of x so that the figures have the same perimeter. Now I know in perimeter I have to add up all the sides. So the first thing I like to do, just to make things easier, is I'm going to mark the rest of my diagram. So I know if they're rectangles, which they are in this case, So I have x is on either side, and I have 6 is on the opposite sides. I'm going to make this x as well, and make this say 2x plus 2. Now I'm going to add everything up. So in my red diagram, I have x plus 6 plus x plus 6, which gives me 2x plus 12. I'm going to set that equal to, and now again, this time I have a lot. I have 2x plus 2 plus x plus 2x plus 2 plus x. When I combine those, I have 2x, and another x is 3x, another 2x is 5x, and so I have equal to 6x total, then when I combine my like terms, plus 4. Now again, there's my wall. I'm going to bring my variables to one side, minus 2x. And I have 12 is equal to 4x plus 4. Subtract 4 from either side, and I have 8x. I'm sorry, I just have 8. Let me get rid of that. 8 is equal to 4x, divide both sides by 4, and x is equal to 2. So if I wanted to, I could check that again like I did on the last problem as well. Now I don't have any units on this one, so we'll just say it's 2 units in general because it's a side, it's not units squared. Squared would be area.